Given the numbers 6, 7, 8, and 9, find a hyperbola with the following properties: a covertex of 6, 7, and a focus of 8, negative 9. Covertex is the midpoint of the imaginary rectangle of the hyperbola that does not correspond to a point on the hyperbola. A pair of non-oblique lines from the covertex and focus will meet at 2 points. Of these 2 points these lines meet at, the one that is closer to the covertex is the center. The focus is always farther away from the center than both vertices in a hyperbola. The lines meet at 8, 7, and 6, negative 9. Of these, 8, 7 is closer to the covertex, so that will be the center. Next, we have the length of the covertex to the center, which is 2, as 8 minus 6 is 2, and the y-coordinates are the same. And the length of the focus to the center, which is 16, as 7 minus negative 9 equals 16, and the other coordinates are the same. Knowing these distances, and knowing the lengths of the covertex, vertex, and focus to the center make up a right triangle, we can find the length of the distances from the center of the vertex and find the vertex. 2 squared plus the length of the vertex squared equals 16 squared. Like, actually writing what those are, we get that the length to the vertex squared is 252. So the length to the vertex will be the square root of 252. Notice that the negative is not here because distance cannot be negative. Since the center to covertex is a horizontal line, the center to vertex is a vertical one. Go to root 252 up and down from the center to find the vertices. The rectangular function that models this equation is this. Because the center is at 8, 7, the y is in front because the hyperbola is vertical, and the 252 and 4 reflect the 2 and the square root of 252 distances squared. We can re-express the 1 as secant squared minus tangent squared because of the identity rules. Therefore, we have the following equation. We can then split the y and x up. We can make this secant and this tangent because we can make this secant and we can make this tangent. We can multiply both sides by the denominators for both equations. So in this case, we would multiply by 252. Then we would square root both sides of the equations and add away the constants, or subtract, or do whatever you can to get rid of the constants from this side and move it here. Then we flip it up so x is on top, y on bottom, just so we can, just for the sake of convention. And that would be your parametric equation.